In this video, we discuss solving trig equations that involve a single trig function. We begin with some reminders about the periodicity of trig functions and then consider 5 specific equations to solve as examples. Let's start with some introductory remarks about the periodicity of the trig functions. The periods of sine, cosine, secant, and cosecant are all 2 pi. Therefore, the function values repeat every 2 pi units. The periods of tangent and cotangent are both pi, so these function values repeat every pi units. Solutions to trigonometric equations will be repeated each period. Therefore, equations will have infinitely many solutions. Often, we will be asked to find solution in some specified period or interval, typically the interval from 0 to 2 pi. Let's solve the equation tangent theta equals the square root of 3. Since no interval is specified for the solutions, we must find all real solutions to this equation. Considering our given equation, we know from the unit circle that the solutions will occur in the first and third quadrants. In fact, all solutions are given by theta equal pi over 3 plus integer multiples of pi. The solutions in the interval from 0 to 2 pi are therefore theta equals pi over 3 plus, and 4 pi over 3. Let's consider a nonlinear trig equation and solve 2 sine squared x minus 1 equals 0 for x in the interval from 0 to 2 pi. This time our solution requires considerably more detail. We have our given equation and want to isolate sine of x. We can add 1 to both sides and divide by 2 to get that sine squared x equals a half. We need to take the square root of both sides and simplify. We have that sine x equals plus or minus root 2 over 2. Separating into 2 equations makes it easy to recognize the special values from the unit circle. The solutions in the interval from 0 to 2 pi are x equal pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now let's solve 3 secant theta minus 1 equal 1. Notice that we are not restricted to any particular interval. Again, we begin with the given equation. We add 1 to both sides and then divide by 3. I like to convert secant to cosine by reciprocating because I have more familiarity and comfort working with the cosine function. We know that the equation cosine theta equal 3 halves has no solutions because the range of the cosine function is from minus 1 to 1. Thus, the original equation has no solutions. Next, let's solve the equation cosecant theta equal negative 2 for theta in the interval from 0 to 4 pi. Again, I like converting cosecant to sine by reciprocating because I have more familiarity and comfort working with the sine function. We start with the given equation. After reciprocating, we want to solve the equation sine theta equal negative a half. We know these values will be in the third and the fourth quadrants. So theta equals 7 pi over 6 plus multiples of 2 pi, or 11 pi over 6 plus multiples of 2 pi. We can get common denominators to make it easy to add the second revolution around the unit circle. Now we calculate the desired solutions by plugging in k equals 0 and k equal 1. So the solutions in the interval from 0 to 4 pi are x equal 7 pi over 6, 11 pi over 6, 19 pi over 6, and 23 pi over 6. Finally, let's solve the equation tangent of the quantity x minus pi over 2 equal 1 for x in the interval from 0 to 2 pi. This equation is slightly more complicated than those we've previously encountered. This time we have a phase shift involved in the trig function. However, we still know that tangent is 1 when the input is pi over 4 plus integer multiples of the period pi. We can add pi over 2 to both sides of this equation and get a common denominator to combine pi over 4 and pi over 2. This represents all solutions to the given equation. Since we only want the solutions in the interval from 0 to 2 pi, we specify that x equals 3 pi over 4 or 7 pi over 4. In the next 2 videos, we will continue considering the solution of trigonometric equations with more involved algebraic techniques.